Hello Jackson, how are you?
Hey everybody, how you doing?
Good, good. We are about to start. Anything that you would like to ask or any questions you have before we
Hi.
start?
So the beginning part, how do you want to do? Are you gonna, what do you
I will
think?
do some, yeah, intro. I
Right?
will it's just all about why we are doing this. It's like a quick, less than 10 minutes, I think 5 minutes, etc. 5, 10 minutes maximum. And then I will hand over to you. And then afterwards, we will hand over to Nigel. So
Great. How you feeling?
good, good. I was just at MetaConnect, so it's quite a little bit jet lag, but it's perfect. But yeah, and then afterwards we will do Q&A. So we will have enough time.
Excellent.
So yeah, if you have, just make sure if you have a video, make sure that you share with sound. I will share the screen first, and then I will hand over the screen sharing to you.
Okay, great. And then once you hand over screen share to me, I am going to do slideshow mode. Um,
Yeah,
and then that's going to be through the basically the overview of RoboFlow. And then
yeah, exactly.
also
You
we're
will
not
see.
live yet, right?
Uh, there are some attendees hearing us, but yeah,
Oh, great.
uh, yeah, we didn't start yet. So, but everyone is joining now. So anyways, we have to wait. I think 3, 4 more minutes because people are coming in.
Great. Ready to
Yeah.
go.
Other than that, we are good to go. There are many people already going in. So we usually wait a few more minutes to make sure everyone is coming. Exactly. You are having a behind the stage opportunity here. Perfect. Oh, yeah, there is one question. It's actually a nice question. Let me answer before we start. Um, For those who have already registered, I think everyone is registered here. You should have received an email with some links. It tells you if you don't know AI CV part, these are the links. If you are new to XR, these are the links. If you are new to like a poker game rules, these are the links. We suggested you guys check these links before. You will still survive if you haven't, but don't worry, you can still survive. But of course, in order to get the best out of this session, we recommend you to check that. Um, since we haven't shared any kit or like a sample project yet, it is not easy for you to follow along. So I suggest that you a little bit like sit back for now, and then basically try to understand and ask your questions. And if you have already registered, the recording of this event or workshop will be sent this week, and you will always go back and then implement by yourself or even use that to bring your own use case. So don't worry about that. Just enjoy and try to understand, ask your questions. That will be the key thing. We are doing, yeah, we are doing quite hands-on here. So don't worry about like follow along right now. I think if you have registered from Eventbrite, you should have received multiple emails. Our team can check if you received as well. We are getting pretty crowded, so let's wait a few more minutes and then we will start. In the meantime, let's do something. I'm really curious to see who is joining today from which part of the world, which city. So, not to hosts and panelists, but to everyone. You can select everyone in the Zoom chat. Tell us where are you joining from today? Wow, Mexico, Louisiana, India, Bengaluru, Germany, Montreal, Texas, South Africa, Portugal, Pakistan, Detroit, Alpha Century, that's interesting. Berlin, Beirut, Peru, Romania. Oh, really? Leipzig, Calgary, Canada, San Francisco, New Jersey, New York, Boston, Seattle, Berlin. Wow, it's amazing. At least, I think this is the first attempt to combine XR and CV on a workshop, on especially on a wearable use case. Um, this means that this is an amazing opportunity that at least there is one, we know that there will be one person who is actually having enough know-how about this very new integration, which will probably dominate the next 5 to 10 years. So we can rely on you that the next meetup you are doing there, that you can talk about a little bit of SensAI Academy, and also mention about this, and then even spread this know-how to the farthest part of the world. Nepal, Italy, Niagara Falls, Seattle, SoCal. Great. That's amazing. Perfect. Let me share my screen. Perfect. I think we are quite crowded now, so we can start. So I think we are really worldwidely covering today, like every other workshop. So I'm really happy that we are kicking this off. Um, the workshop is Can Vision AI beat poker, as you know. So we are hosting this workshop for the next 1.5 hours or 2 hours. It is based on how many questions you have. And just I want to make sure that don't hesitate to ask your questions. This is, even though this is that one part is workshop, that you will have an hands-on understanding, both from the computer vision AI side, and also another is XR side. I suggest that you definitely ask any questions. This is really your session that we want to make sure that you take away something useful today by the end of today. So I would like to thank you to the Roboflow team, especially Jackson, who is with us today. I will hand over to him in a few minutes. We have been working with Roboflow for the last couple of months to like joining forces on and understanding how we can bring XR and CV audience together. As you know, as SensAI Academy, we are really pushing for this, how we can bring use cases on this intersection. Computer vision was something which is already very popular, like and widely used, especially by industry setting, which you will learn a little bit today. And XR is also out there, but they had not so much had the chance to meet, join forces. Now we are actually bringing that together. That's why we created this whole SensAI, which I will explain a little bit. And a little bit SensAI about SensAI. As you have seen, maybe the announcements, recent announcements, especially Meta Connect. If you watch Michael Abrash, chief scientist of Meta, talk, I was there in person. I was lucky to be there in person, and I lost count how many times he talks about senses this year. So it was actually a nice coincidence for us to see that actually it's all about mimicking senses. It's all about mimicking human cognition. Of course, coming to that human fidelity level is not easy. We have a long way to go, but our goal is actually by using the existing, maybe a little bit limited capabilities that we can replicate, we can mimic these senses. We want to utilize that to one, to collect data so you can actually understand the world better, have a much better context awareness, full context awareness, especially from the hearing and vision. There are a lot of things going on which we will learn the vision part today via Roboflow. But the second thing is also creating apps, right? Like how we can utilize this intelligence plus these sensing capabilities in the best way possible that make enhance our life easier or make much more convenient, bring much more convenience to our life, daily life, business life, industry. So we have seen a lot of examples from even last week's announcement at Meta Connect from smart glasses. So we are basically bringing that first through a headset, Meta Quest, you will see today, but eventually all these use cases is directly applicable for smart glasses as well. So that's why we have recently announced SensAI Hackademy. It's like a global program that you can join. Our team is now sharing the link with you, sensaiacademy.com. Um, Again, it's all about senses, and we really want to make sure that XR, CV, AI, and mobile devs teaming up together to create a cross-functional breakthrough and use cases. Every function, every discipline is knowing, of course, their own part, but we want to also close the skills gap there because most of the XR people, Unity people that we are talking with have limited idea about machine learning and computer vision. And when we talk with the computer vision experts, they are senior on their field, but they have not touched any XR headset or glasses before or Unity game engine before. So we want to actually combine this and also bringing also mobile devs to especially for smart glasses. As you know, we are known for hackathons year long. We have so many hackathons which I will explain in a bit, and lots of dev kits, wearables announcements coming soon. I We have so many surprises and so many exciting news coming up. If I were you, I would really apply the Academy today and be the first one who is actually accessing to these amazing free opportunities. It's all about community growth and creating a frontier apps unique apps that will help your career, that will help your next project, and that will help your studio. So we have done a lot this year at MIT, at Harvard, at AWE, lots of events going on. And then we have also done lots of workshops, hackathons, and this event is actually one of them. You can also follow us on the Eventbrite as well, and our newsletter will give you a lot of idea about what's going on, because we are just starting. Like this 20 workshops, hackathons, I would say this is just the beginning. We have tons of other things coming up. And the next one is real-time ball tracking with camera access computer vision. I don't know if you know Christoph, but he's doing an amazing project that can track a real-time moving ball. And it's one of the most difficult tracking because it's not static object. So we are so happy to have him next week. This time on Wednesday, same time at 10 a.m. PT, 7 p.m. CET. And if you maybe have already newsletter, or if you check our Eventbrite, our team will also share the Eventbrite link with you. So you can already register for next week event. As I mentioned, this is just the beginning, and we would like to make sure that we are providing the cutting edge use cases so you can actually get inspired from that. And hackathons, right? Like, okay, we learned a lot from these workshops where we will implement. We have a lot of interesting workshops coming up. You will have access to some crazy tech that no other hackathon that you may have access. I can just tell you that we will have lots of like surprise announcements coming up. The next two hacks will happen in Barcelona and San Francisco. So feel free to join the next hacks, SensAI Our team is also sharing the link right now of the hack page, so you can directly apply. Feel free to apply quickly because sometimes we have limited space, so you may not maybe you may be a little bit late if in case it's booked out. And for those who cannot basically travel to these locations, there's, as you see in this event, there are lots of online opportunities, but also a potential online hack. Again, stay tuned. We will have very interesting announcements in the next couple of weeks. Yes, so what we did so far in the hackathons, maybe you have seen that we did one hackathon pre-Gamescom, and our team created really amazing kits. This one is, as far as we know, world's first Unity plugin zero-shot object detection running on Quest, and it helps you to actually detect without any training, any setup. It works out of the box. Of course, compared to pre-trained models, it takes a little bit more time, and you cannot have like a hyper accuracy, but still it's perfect for if you really want to create like a detect objects on a complex environment. And this was already provided to the hackers. We are so happy that we can really bring it to as many developers as possible. We have also one more kit, but this one you will already see today. So I would suggest that bear with us to see the other kits that we will release today. And based on that, it's very interesting because normally we are seeing camera access and computer vision on a normal hackathon 10%. And with the help of these kits, even though integrating CV is not an easy task, even for an expert person, we basically managed to bring the number of CV projects on an XR device from 10% to 67%. So this is an amazing opportunity for you to try out this integration, this unique project, first time in your maybe career, and stand out, right? That's the beauty of it, that we help you to build something that you have never built before, and then break into another field, right? To CV. And for those who are computer vision engineers, vision AI experts here, they are also breaking into XR. This is an amazing opportunity. So I want to now hand over to the Roboflow team without further ado. Just want to tell you that you will see a lot of things today. We will probably talk more, but I really want to thank to our team, Nigel and Jackson. We have been working on this workshop, this project for months, just to make sure that we are providing something useful, interesting, that will be maybe the kickstart of your career in terms of XRCV integration. So happy to see Roboflow team here, and I would like to hand over to Jackson for his Roboflow overview. Let me stop sharing so you can take over.
All right, Farhan, thank you so much. Just want to check, is it looking right?
Yeah, you can also make it share, so like a full screen. F11 you can do.
Let's do full screen. Let's do it. Maximum. How's this?
Yes, it is good. Just give me 1 second. We will also have one poll that I would like to share just to make sure how is our audience. So this will give us a lot of idea. So while you are listening, you can also like basically look at the poll and then answer, because this will also give us a lot of idea what is the audience, and then we can basically arrange accordingly. So stage is yours, Jackson.
Amazing. Awesome. Thank you so much, Farhan. It's been really great to prepare this with you all, and thank you for instigating it. This is your idea. So I'm very happy to be here as a guest, and I'm ready to dive in. As a brief sort of structural overview here, first of all, my name is Jackson. I am on the Roboflow team, on the growth team. I sort of do both marketing and product. So I'm building features and then also doing events like this, engaging with our developer community. And what I'll do now is it'll be 3 parts, and we're going to move as efficiently as possible. First part is just overview. What is Roboflow? What is computer vision? What is this tool that we've made available? And then part 2 will be we're actually going to use the tool, and that'll be maybe 15 minutes or so. We'll build a computer vision model. And then part 3 is we will prepare it in a way for Nigel to take over and embed that computer vision model inside of the smart glasses. So 3-parter, we'll start with a brief presentation. What is Roboflow? What is computer vision? Essentially what we do is we give you, your software, the sense of sight. That's our nice little tagline. The key takeaway I would love for everyone here to have, if you are not experienced in computer vision, is that this is incredibly sophisticated technology. We're sort of at the cutting edge, and our whole goal is to make it as easy as possible for a regular developer. That is someone who doesn't have deep machine learning expertise to get up and running with computer vision today in a few minutes, in a few seconds even. That's our whole goal. And if there's one thing that you take away from this, obviously, I hope that there's many, many, many things you take away. But if there's one thing, it's just like, oh, it is that easy. They've put a ton of effort into making it very easy to get started. Okay, now, I said we're giving your software the sense of sight. We're a computer vision company. What is computer vision? Essentially what computer vision is it's software that understands what's inside of an image and then therefore what's inside of a video as well, because obviously a video is just a series of images. So let's look at these examples here. On the left, we have a video of a conveyor belt where there are orange and brown candies that are moving across it. The sort of thing I want you to be thinking about is we are the model that allows you to, we allow you to build the model that allows you to identify those candies, which you can then take that information, give it to a robot, and it can sort those candies correctly and efficiently. So one of the things that you'll sort of easily jump to the conclusion of is that Roboflow is very, very helpful in a factory environment. and in an automation environment. On the right side, we have a video where the model is picking up cars. Oops. Where the model is picking up cars at an intersection. So this is another use case, is monitoring flows of traffic. Really, there's anything where there's an image involved and you want to understand what's happening inside of it, that is where you would use computer vision. So I'm going to go through a few more examples now. These are sort of cool videos to spark the imagination a little bit. Here is using computer vision to detect players on a field. You're also, importantly, you'll notice you are detecting players throughout the course of a video. So an object is created, and then you are tracking that object throughout the course of a video. Cool stuff. Next is, this is we don't need the volume. This is just showing one of our open source packages that's really powerful called Supervision, where you can detect objects in a scene and then label them very beautifully. I love looking at all these options. So you have the corner frame, heat map, sort of a gradient, shadow, etc. Very cool. Next is another use case. Here's a highway, cars, and with a little bit of added logic on top of the actual AI model detections, you can figure out how fast a car is going. And here's a fun one that was built internally by our team recently. They have a camera on which you can see in the bottom left. And then there's a model that is running that detects furry little raccoons, and a little bit of extra logic in the middle that is sort of on the camera, where you are detecting the object and then placing it in the center of the frame with a nice lag to it so it's not too jarring. So anyway, those are some ways to kind of get a little bit of inspiration of what's possible with computer vision. And then I also think it's very helpful to think of, like, at a high level, what's going on here is different than something like a GPT-4 or Claude Sonnet 3.5, where you have that. So in sort of the large language model world, you have these massive pre-trained models that have a ton of breadth and depth information. You can ask it about, a PhD over here and then a totally different field over here. That's not the case with vision foundation models, which have their equivalents to a GPT-4. We've built our own foundation models, and then there's also sort of a very popular series called YOLO. So there are vision foundation models, and the difference is they don't have that massive breadth of information. They really just understand a few things, which is why I think that illustration is a pretty good one. There's only 6 circles there. That's like almost order of magnitude how much an out-of-the-box foundation model and vision will understand. And so what Roboflow does is we allow you to enhance the intelligence of that model and add another node on that graph. And then the other thing that we do is we then make it very easy to take that fine-tuned model, that refined intelligence, and then put it into production. So in the context of today's talk, the foundation model, if I gave it that picture of a card that is an ace of spades, it would not know what that is. We're going to fine-tune a model together to understand what is an ace of spades, and it will detect it. And then I will give that to Nigel, who will put that into production in glasses. And then a nice metaphor here is fine-tuning is sort of the student to expert path. So a student has raw intelligence. They're arriving on campus the first day. They have a great brain. That is the foundation model, but they don't know anything. You give them books and a great teacher. That would be data in the form of labeled images and GPUs and model training architecture as the teacher. So you give them really great books and a good teacher, and then over time, if enough time will pass, they'll become an expert in that, whatever you've taught them. So that is the fine-tuned model, and that's really where our core competency is as a company. There's a lot of stuff we do. We try to understand everything about computer vision, and it's a beautiful, complex, massive field. But that's really the sort of the sweet spot, is we take those foundation models and we fine-tune them in a particular domain. Okay, now what is it? So that's sort of high level. What is Roboflow? Some inspirational examples of what's possible, and then maybe a metaphor to sort of wrap your head around what we're doing. And now here, more tactically, is the actual computer vision flow that we built out into a product at Roboflow. It's 4 steps. The first step is you have to choose your project type. There's 4 classic types. You are either drawing boxes around an object, you're drawing specific shapes around an object. That's segmentation or polygons. You are labeling the entire image. That's classification. So hot dog, not hot dog, damaged, not damaged, big broad stroke stuff and classification. And then key point is you're like doing pose estimation and skeleton structures. I also ordered that in the rank order of what is most common. So the most common use of computer vision is object detection. It's that leftmost image is drawing bounding boxes around something and counting them in the image and then building logic on top of that. Part two is Roboflow Annotate. So it's that in sort of the metaphor, it is the books part. It is choosing the right books. And in our case, that is labeled images. So we have extensive data set management and labeling tools available for you to feed to the model to improve it and create that fine-tuned version. So part one is choose your project type. Part two is start labeling and gathering data. Part three is train the model. And we sort of make that one-click button, train. I mean, there's a bunch of stuff that you can do within Roboflow to optimize it. Today, we're going to go the happy path and just do the one-button train, and it'll be sort of ready for us instantly. And then the actual deployment part, and this is that part three, putting it into production. Conceptually, so we have a visual workflow builder, which you can see in the GIF there, that allows you to stitch together models and also stitch together logic and basically wrap that model that you created and anything you want to build around it in an API endpoint that you can hit from anywhere. And when I say anywhere, that includes on the cloud, on a local device, on your iOS, and then again, in today's example, it's going to be Nigel deploying it locally in the glasses. Okay, this is the last slide before we build the model. So great patience, everyone, with the slides. We're going to get into the actual demo here in a second. But this, I think, is the secret weapon of Roboflow. And it might be your also, if you have used Roboflow, it might be your foray into the product itself, which is Roboflow Universe. And the basic idea there is if you sign up for Roboflow and you use it, you build a model, you create a data set, you create a project, and you're on the public plan, which is very common, that will join our massive repository of other public projects on Roboflow Universe that anyone can use. Over time, this has become the largest open source collection of data sets and models on the web in the world. These, again, are made by other Roboflow users, and they're ready for immediate use. The coolest part about all this, I think, is that Nigel later on, we're going to build a model right now together, but Nigel later on is going to literally just use a model that already exists on Roboflow Universe to detect cards, and he'll use that for his side of the project. So there's a ton of already ready to go pre-trained models for you to use at Roboflow Universe. I'd recommend you checking it out. Okay, let's do it. I'm going to go off my screen here. I'm going to ask very briefly if I'm going to ask my fellow host and panelists if they can see the browser as it is right now, showing Roboflow login.
Yes.
Okay, perfect.
We can see.
Great.
Yeah.
Just wanted to check.
Yeah.
Great. So now we're going to actually build this model. Let's do it. Signing in. Everyone, fingers crossed. The demo odds, let them be in our favor here. Okay, so I have already created a few projects, so you don't see the default screen that shows up. It's not worth showing. Maybe I'll just show it really briefly. It's this screen right here. So if you had just signed up, you would see this build vision models to recognize anything screen. But I've already created a few models, so there's 3 that are populated there. So we're going to run through again right now. We're going to build a model together right now. Let's do it. So new project. Actually, before I do that, let's make sure we, 1 second. I'm just going to orient everyone. So project on the left side, that is where you build your model. Workflows, that is that visual workflow builder. That is where you deploy the model into production. Monitoring and deployments, you don't need to worry about those right now. That's not really relevant for our demo today. That's more of on the optimization front. And then explore, that is where you go to Roboflow Universe and you check out those other pre-trained models and data sets. So we will start by building a model. So I'm going to create a new project. Let's call this Detect Aces demo. Now, I'm calling it detect aces and not detect all playing cards because for the sake of today's demo, to speed things up, we're just going to focus on detecting ace of spades. That shows everything you need to know, but that's the plan. So now if this was the actual full detect all 52 cards, we'd call it something different, and there'd be different, later on there'd be different classes that we'll use. But for now, detect just the aces. Let's say this, playing cards, license open. And then remember, these are those 4 project types that we can choose from. The one that's most relevant to us is just those bounding boxes, is the most popular form of computer vision. So let's create this public project. No. Smart. Okay. So the first thing is those books, right? We need to take the foundation model, which is an object detection model, and we need to create a data set, a bunch of books that is relevant to, sorry, a bunch of images. The metaphor is going too far. A bunch of images, labeled images that help us fine tune this model. I've prepared a folder here full of images of cards. So we'll upload these together. And one important thing to note while these load is the flow on the left here, also chronological. We're going to upload data. We're going to annotate it. After it's annotated, we will create an official data set. And then that official data set will be what we'll use to fine tune the model. Okay, so this data is all uploaded. We have 33 images. As a small caveat, 33 is low. You'd want to have at least 70. And then in the model that we're going to use later, it's actually 10,000 images. So it's not necessarily true that more images is better, but definitely 33 is, you'd want more than 33. I'm going to opt to label these myself. And here's a nice pop-up that tells you the key things. You want to make sure that you're labeling every relevant object in the image. Tight bounding boxes, no lazy bounding boxes. And your data should be representative of the thing that you want at the end. And then, as I said, about 70 images will get you started. But 33 is okay for right now. So, if I can't remember what that show is, but the da da da, this is gonna be a little bit of that. Or I'm gonna label these over the next like 90 seconds. I'm gonna try to talk over it, but I'm also focused on getting these bounding boxes correct. So we're gonna create a new class called AS. That'll be Ace of Spades. There you go. We've labeled one, and we're going to get it tight. We've labeled another, and that I don't see any other ace of spades in this image, so I'll go to the next one. Here is another one. Nothing here, so I'm just going to mark that as null. Nothing there. Go to the next one. We'll zoom in. Boom. Bam. Next, I am going to keep doing this manually. However, it's important to note that we've built a bunch of tools on the side here, Smart Polygon, Label Assist, Box Prompting, that can automate parts of this process. I'm not going to do that because we don't have a lot of images to work with. This will be over in just a minute. But there are many annotation sort of efficiencies available to you. Okay, that's the only one there. And soon here at about 15, there starts to be a lot of null classes, a lot of images without any ace of spades, so that'll speed things up. Okay, that's a null. Here's one. Make sure got that. There you go. Nothing in here. Null. Oh, this is a blurry one. It will be able to pick this up. So the general rule of thumb here with computer vision is that if you can see it with your own eyes, these models can too. They're really, really very sophisticated. So even though it was incredibly blurred, that one we did just a few ago, the model we build will be able to pick that up. Right? Cruising. Okay, here we go. Now we're in our little null pile, I think. Yes. Okay, I don't see any. Don't see any. Don't see any. None. 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 You're doing great, folks. Stick with me. Almost done. Or no. Make sure that was marked, yes. Or no. Getting close. This is on the ground data labeling in Roboflow. No stone unturned. We're going slide by slide here together. Okay. Oops. Okay. Almost done. Just a few more. Remember, get it really tight. Boom. Boom. And nothing there. Let's see if there's anything here. Yep. Maybe there's the last three sort of abnormally placed. Important to have variance. The more sort of visual diversity you have in your images, the better. So I guess it's more of it's a combination of you want it to really look like the production environment, and you also want there to be diversity of the images overall. Okay, so we're good to go. That's 33 images. We're going to add these images to the data set. And here's where we start to move into the training portion. This is the classic way to split your data set. You have 90% of it is involved, train and valid. 90% of it is involved in fine-tuning the model. And then the 10% that test, those 3 images, those are not going to be part of the training process. That is how we'll see if the model actually works. So at the end, we'll look at those 3 images and we'll say, does it work? Either it will show ace of spades or it won't. So let's add these, and we've created our data set. So now this is an official packaged data set. It's a committed data set. And now we will do a Roboflow instant model. Purely because this is the easiest way for me to deploy and keep this demo quick. So a Roboflow instant model is like our super lightweight, immediately ready to go deployed model. There are a lot of custom model creation things that you can do once you have a data set. So we could go through this custom train process, and to be honest, it's not it's actually not that long. It'll take maybe 20 minutes for it to train. It's a few buttons clicked here, and then 20 minutes of training. But for the sake of speed, we're just going to roll with this Roboflow instant. And we're going to click deploy. And this is now where we move to that last phase of deploying the model into production. So this brings us to the workflows. This is a template workflow ready to go. This is our visual builder. And as a little tour of the builder, this object detection model here is what we just built. This is our Roboflow instant model. The input, right, is going to be an image. That image is going to go into the model, and then the output of that model will be, we'll label it with a bounding box and a label that says AS, and we'll also have a count objects. But you can create there are tons and tons of blocks that you can use to add notifications, transformations, more advanced things, custom Python blocks, other models. So you can run an object detection model up here, and then to detect specifically ace of spades, and then you can run another one that's maybe a class of, or maybe you could do just like there's infinite things you could do, but you can chain models together as sort of part of workflows. Really powerful. Now the key here is, does it work? We're going to try. Presentation materials, ace. So here is an image of an ace of spades. Ideally, this workflow out of the box will detect what's inside. Let's see. Definitely not. But wait, hold on. Maybe it does. So this is what we're looking at is clearly ace of spades is not being detected. At least it doesn't look like it. Let's go back in here. What's happening is it's just a little bit too sensitive right now. If we lower the sensitivity, which in this case is increasing the confidence, those words really don't matter. Basically, what you just saw was less bounding boxes, and this confidence threshold, the higher it is, the lower boxes you'll see. So I have gone through this demo before, so I know that at about 0.91, confident. So 91% confident that that is an ace of spades. At about that point, you'll see things start to converge correctly. So let's try 0.92 just for variance sake. Let's test this workflow again. Let's run it. And there you go. So that model just detected and labeled an ace of spades in an image. And that all was in, I don't know, hopefully I'm not way over time here, but just a few minutes. So that is the sort of end-to-end Roboflow process of building the model and testing that it works. Now we're going to move into deployment. I will say for most of my side projects, I use Roboflow through the web, through an API, right? I'll have a JavaScript fetch here, and all you got to do is copy and paste. But for today's example, we are doing a local server because we can't be waiting for we can't be waiting on network requests through our glasses. It won't be real time. We're looking for real time inference. And so the way to do that is to take Roboflow, the inference server, and put it on our computer and give it access to those glasses. So this is, again, this is in that initial sort of outline of this presentation today. First was high-level overview. Second was how do you build a model and test that it works. And then now we're in this phase 3 here, which is how do we locally get it set up. So I'm going to work through that step by step. I'm going to stop my screen share. I'm going to re-screen share with my whole desktop. You'll be able to see, it all. And we'll dive in for the last step here. Oops, hold on. Okay, so now I'm just briefly back to the presentation. Briefly back to the presentation here. Now we are deploying it locally. There's really two things to do, or two important slides. One is a little bit of prep work. The key things are you definitely need to have Python version 3.8 to below 3.13. One of the reasons why I'm mentioning this right now, I actually just raised this with the team, is if you go to our documents, inference.roboflow.com, getting started, it says above 3.8. And interestingly, if you go to Python and you download it straight up, the automatic version is 3.13. I just raised this with the team a few days ago. We're going to change the instructions here up top to be very clear that it is Python greater than or equal to 3.18 and less than 3.13. There are some dependencies within the inference package from Roboflow that don't work well with 3.13. One way to test this is I'm going to go to my terminal here, and let's go to XRAI demo 3. I'm going to check the Python version. So make sure you're at below 3.13 and above 3.8. Okay. So that's step 1. Happy to answer any questions specifically about that. Step 2, also mentioned in our getting started docs, is we're going to do self-hosting, right? The sort of recommended route here is to run via Docker. So first thing is first, got to install Docker, go through this brief process. What is Docker for anyone not familiar? At a super high level, very basic. It takes all the dependencies, everything that a project will rely on to run correctly, takes all the versions and it locks them. So you're not subject to someone updating a library over here and it crashing your system. So if you're not familiar with Docker, definitely check it out. 100% for this one, I recommend installing it, and that lets us set up local inference. Okay. So for step 4 here, we're going to create a new project locally. Terminal. Oops. So here's what we're going to do. We're going to make a new directory. We'll call this XR demo 4. We will inside there. Okay. So we're inside here. And we're going to activate virtual environment. Again, I'm going to test first. Do I have the right Python version? Yes. And for anyone who's unfamiliar with how Python works, Python automatically globally downloads versions of packages that you download from the web. And so one way to get the main way that you get around that is by within a specific file, you have local versions of everything, which we do with this guy here. So what we're doing right now is we're spinning up a little environment for me to hold dependencies, and then environment bin activate. This is sort of the classic way to get started with a Python project. Is you spin up a virtual environment and then you activate it. So now we are in a local environment for this demo. That is the prep work required to get started. And now we do the actual installation steps. And what we're going to do by the end of this is on our local computer, we'll have successfully run this workflow that we created earlier. Okay. And then I'll pass it over to Nigel, but let's do this. And to make it very clear, let's follow the instructions in inference in our inference docs. First things first, all the CLI. This is where we need that background music. Next time. We are installing these things live, by the way. That is a real demo. Okay, and now for the key next step, which is inference server start. What that's going to do is call upon Docker, which we've already installed. Again, that's part of the prep work of this. Hey, what are you doing here? Okay, well, we're going to run this. I have another container running. I'm going to go over it. Okay, so now we have Docker running. That's our sort of our two commands to get started. And now we're going to start coding. And part of the, so what we just did is we set up the environment, and now we're going to get to the code. Let's look inside here. Let's use cursor because it's great. This is our project folder. Now we're gonna let's see, poker detection. Card detection, ace detection folder. We go inside and touch. So what we did is just create a folder, and this is gonna be our little Hello World project. Let's run that to make sure that things are running smoothly. Nothing in there, that's why it didn't work. There you go. Nice, so we have Hello World. Now, let's go back to the docs. Let's go here. Oh, we didn't actually run this yet, did we? No. Let's make sure we have the inference SDK run as well. Nice. Okay, and then this is the example from Roboflow team. Let's do run generic workflow file. Nice. And it'll give you some basic info there about what an inference using Python looks like locally. And now let's run it. I will say we are at risk of this taking just a half step too long. So the one thing that's happening right now, again, we are working through these inference docs. We're just running an example workflow. This is like a public workflow from our team that you can run, and the output of it is it'll print a bunch of predictions. So that just worked correctly. These are the predictions. You don't need to look too closely into what those are right now, but just getting those back is the correct response. So that's our generic workflow. And now let's create another document. This is going to be our custom workflow, so the one that we just made, that Roboflow instant model. So run custom workflow, Pi, right? And what we're going to do is go back to the deployments tab here. We're going to go to local server, inference SDK, that's what we're using. Copy this. And It is exactly what the generic is, except it includes our API key to our workspace, and we'll be referencing a local image. So let's put, really like this guy. Let's put it in there. So now this custom workflow is going to run inference on this exact same image. And we should see the same result. Or actually, just for now, we should just see the predictions. So let's do this. Again, this also may take a second. Classic procedural note. Once you deploy a model with Roboflow, the first time you use it, the first time you're on inference, it might be a little bit slower. But then every time after that, especially if you're on a free plan, every time after that, it speeds up. Again, remember the loading background music. Jeopardy. Almost done. Maybe this is a good time for a poll or something. Should take only a few more seconds. Also to note, we are right here in our local inference step by step. We just have one more after this, which will include the literal visualizations. Okay, great. So as you can see, we have back the predictions. Again, we don't need to look too closely at this. This output is exactly the same as this JSON, or it should be. Let's see if, yeah, you show the raw JSON. So there's a base 64 value. There you go. So all that's in there. So this successfully just took this workflow that we created, the model that we just created right now, and locally accessed it using Inference SDK, and we ran those predictions. Awesome. The not awesome part, which is why we need this last step, is we're looking at a bunch of numbers. That's not super helpful. So let's actually visualize it, and then once I'm done with that, I can pass it over to Nigel, and we can move on to phase 2. Here we go. So let's create a new final doc here, which is run visualizations. And I'm going to cheat just a little bit. I made this guy beforehand. All right. So let's start with this guy, which is the file we just created. So we just ran, everything that's not commented out right now is exactly what we just used. Now we're going to apply those visualizations. The way to do that is with a GitHub repo that's very popular called Supervision, which is maintained by someone on our team, maintained and built by our team generally, but also sort of our main contributor. The main contributor to Supervision, the main person responsible for it is Peter on our team. It is a fantastic repo and very popular. Let's make sure we have installed it. So pip install Supervision. A lot of these demos that a lot of the demos that I showed earlier come from this repo. It's really, really powerful. So I'd recommend everyone to go and check out Supervision. It is the Swiss Army knife of CV operations. Okay, we just downloaded it, which means we're ready to use it. We're going to import that, and I'll just walk through this step by step. We have loading that image in. We then are going to use those predictions that we get back. We're going to instantiate Supervision. We will annotate the image, and then we will display a pop-up window with the annotated image. If all goes well, we should see this on our local computer. Here we go. Oh, no, we didn't do it. What happened, folks? Let's see. Model prediction is the key error because it's so classic. A little fast thinking here. Should be model predictions. Let's go here. Well, first of all, come on. So here we have predictions. I bet it is just, it's just a key value that's different. There you go. I just had a wrong key value. And now, success, ace of spades. Okay, I'm going to give this screen up. I'm going to stop my share, but I just want to do the sort of last thing, which is what you just did, what we just did together, which is we built a model. We made it available locally. We ran inference locally. Success.
Amazing, amazing. I was just at MetaConnect last week, so even the live AI demo failed. We even did live vision AI demo here. I think we did a much better job than Meta. So congrats, Jackson. It's amazing.
We
Great.
did it.
Exactly, exactly. Great, great. So that's great. We never hesitate to do live demos. But before going to the Nigel's part, I would like to a little bit clean up the questions related with Roboflow. We also shared the links that you shared, but just to maybe quickly, should we go quickly the questions before we hand over to Nigel? Because there are some questions directly related with the data set and Roboflow part. I want to clean that up before we start the integration part. Everyone who is having any question, please make sure that you are writing under Q&A. There are already quite a bit of questions. So let's keep it quickly answering. You can also answer some of them by writing. So we don't need to answer if there is some link or something that you can quickly give an answer. But let's start from first one. Will the dataset be available on the Roboflow website or it's a custom made one? So you will share the link and then we can share with everyone after this session with the recording, kit, dataset and everything, right? Just to make sure.
Totally. Yep. The data set that I just created, which again is only 33 images. So I wouldn't actually recommend making that your production use database. That will be available after this if everyone would like it. Happy to make that available, yes. And
Great.
I'm actually thinking, Farhan, right now, if it would be valuable, I'm not sure of a very quick of very quickly looking at Roboflow Universe for
Exactly.
what Nigel will create right now.
Exactly.
Should we do that? That'll take me like
Yeah.
2 minutes. Should we do that right now?
Yeah. I was about to say Roboflow Universe guiding. Yeah, let's do that. Maybe let's answer these questions and then do that and then start the Nigel.
And that'll be super quick.
One
Great.
more, yeah, one more thing that I'm adding. Can I only use free package of Roboflow to do all of these things, at least the ones that you showed today? Is it possible?
Everything I did today is totally free. And to be clear, I showed you the tip of the iceberg. So there's a ton of free resources and tooling that you can use. And we have a free tier that has a ton of credits built in for you to play around with.
Amazing. And it's like an open source data set. So we are basically benefiting from communities, huge work of years of work, right? Like huge
Totally.
training. So this is an amazing, like a gem or treasure, I would call it.
Yes.
So how do we connect it to an external camera? I don't know if this question is like a webcam or like a camera of headset, but yeah, this is something that can you maybe quickly tell us how you are connected to external camera? Is there anything that especially I understand it's like for real time detection they are asking?
Yes. So if I'm not going to make this very long. I'm just going to share very briefly.
Okay.
So you can basically deploy however you want. And we have docs for doing all of this. And that includes, actually, I don't know if what I just shared is very helpful, but maybe the best thing is let me just drop a link in chat,
Yes,
which links to our docs, and that'll show
perfect.
exactly what
So
you need.
Saul's question, I'm keeping it under Q&A, so you can directly answer there, so everyone can see that as well.
Right.
Hardware requirements for running this model, is it like running in any kind of thing, or is it like very recommended hardware?
So what we just did is we used Roboflow hosted infrastructure, which means it's ready to go through the cloud for you, and we handle all the complexities of the infrastructure side of it.
And like it's
And
running in
on
browser anyways, so
running in browser, yeah. I
yeah.
mean, for the local part of it, I just don't actually have the depth of I actually just don't know what the requirements are. I'm sure there are requirements, and I can follow up with what those are. But we were just using our CPU, our computer CPU. And I'm on a MacBook Air here, which is powerful, but it's not like you need some serious hardware to pull it off.
Okay.
And you don't
Anyways,
need a GPU, even though that's very helpful.
yeah, Nigel will probably show what are the requirements on the hardware side of on the XR side. Do we need smart glasses to support RTCP protocol to support live object detection? I think this is a question that Nigel may answer. So I'm leaving these smart glass questions or headset questions. Why not bound the entire card? Does it make a difference?
Ah, nice. Yeah, that is 100% our decision within the process of making this model. We could have detected the entire card. That is just a different fine-tuned model. But yeah, you could totally do that.
Perfect. How does the auto annotation tools work? I would love to see more about this. Maybe you can also create a link, share a link for under Abhishek's question. Anything you want to share about
Let me
auto
sh
annotation?
Yep. Let me share something right now,
Okay,
which is a link to a video that we made 2 months ago, which is a very direct response to that question of how auto labeling works. It's very cool. You basically you take the first image, you make one object detection annotation, you click auto label, it does consume credits, um, and then it will predict where it thinks that exists elsewhere in your data set. So that's how you can start with maybe 100 images, and sort of a mini model is created in those first 100 images that you create, and then you expand that to, and then you click auto label, and it'll expand to 1,000 or 2,000 or 10,000. That's how you can. That's one like way to actually get through labeling 10,000 images is our auto label feature.
great. What happens when you label a value as a non-value, no ace but spades? Would that affect the model's confidence to detect it?
Are you asking what happens if so in the data set that I had, there were maybe half and half null versus actual labeled images. Is that the question? Like basically, what is the function of those null images?
Yeah, it says label a value as a non-value, like a no ace but spades. Like a non-value is
Yeah.
is Kathy's question.
Yeah, I think that is um,
So the question is, would that affect the model's confidence to detect it?
outside my expertise. That's for the models team. That's why we have, computer vision engineers I don't
Yeah,
know. I'm not sure. I don't know what the right balance is of like null images that don't have an object, like a label inside of it versus ones that do actually have a label inside of it. Um, so I don't know. And I think a lot of this too, importantly, really briefly, is that a bunch of building models is a vibe test. And so it's up to you to like try out and see what works for your actual production case and what doesn't. So I don't know.
XR people are also very used to iteration and
Yeah,
trying prototyping, so I think it will be great. Do you
great.
need,
Adam, love it. This is
yeah,
why I love it. From a CV model perspective, it does matter. Of course, totally matters.
exactly.
Yes.
Perfect. Do you need as many as non-annotated images as annotated for data balance? Does object detection just need bunch of annotated images?
You could just do a bunch of annotated images. Yes, correct.
Okay,
You could be
perfect.
100% annotated. Yeah.
Is it a bad practice to select the entire card?
That is, again, back to the first question. We just decided to make our object detection model only focus on the value suit combo and not the full card. But we could have done the full card if we wanted to.
Yeah, there were some questions I told you, Jackson, as well. Like some people are really wanting to create something which is not in the universe, but they want to do their own, right? How to take photo, etc. I think we already showed a bunch of it, but just to maybe inform everyone that if someone wants to train by themselves, what are the best photo shooting practices that they can have? Maybe we can also tap into that. Is there any guide how image should be like, resolution, size of images in Roboflow? I think that's relevant to my question. So resolution, size of image, like in order to, I think, pre-train model.
Yes. So we have image size. The general rule of thumb is actually smaller is better. You don't need to overload it with pixels. I think 640 by 640 is kind of a recommended size. And then we have limits. We have sort of upper level limits on images that I think it can't be more than 20 megabytes and it can't be more than 1600 by or 16,000 by 16,000 pixels. But generally, actually, the smaller is the better. It also reduces compute time. So if you there's sort of a balance right at 640 by 640 that I think is best.
Okay, great. Um, Question about locally set Roboflow servers. Suppose I built an app or a game. How do I make the user use a local server? Does the user need to host on his local computer? Is it a question for Nigel or you? Locally set Roboflow server.
Yeah, so what we just did is we did fully local on my machine. If you were to build an iOS app, for example, that you wanted the model to run on the app itself, I actually don't know how that works. Um,
How you are making the user use your server? I think that's the question. Your local server.
yeah, let's see. How would you make the user use your server? Um, I think a lot of times it would be through the cloud. Otherwise, um, so an example is like we work with companies like Rivian. We will install hardware in their factory and they will use
Hmm.
it there. So they won't even be like we'll have a monitoring system that plugs into that sort of throws back information to us, but they're doing their thing. So
Yeah.
if
But
it's
I
that,
think it's a
if
question about much more like a consumer app. Like I
yeah,
have
yeah, yeah.
consumer app that is maybe there's
Boom.
something that Nigel can share in his presentation,
And
especially
rock, yeah.
for those who are building on Metastore. Um, why do we need the local server? Can't we use the model directly in the Unity project? I think this is a question I will leave up to Nigel since it's Unity. What is the inference time per image if it's a medium weight model running on MacBook?
I don't know. That's a very specific question. I don't
Okay.
know.
Okay, it's a very specific question, yeah. But maybe you can guide people to Roboflow forums or Discord, maybe for this kind of questions. So that might
Yeah, exactly. One thing I will say is, which I don't think I fully emphasized, is today you can use ChatGPT, for example, to tell you what's inside of an image. So there are visual capabilities in language models, but if you ask ChatGPT like, hey, what's inside this image, it'll take 3 seconds to respond. The key thing that you're doing with RoboFlow is you're getting like we're building real-time models where the latency should be basically immediate, where you send an image and you're immediately getting back those detections.
Okay. Is there any particular reason you used supervision Python code for all the visualization steps instead of just building those in the workflow and then letting that output all the visualizations?
Could have done that totally.
Okay, perfect. Okay, there's another question about laptop specs, but yeah, I think you will share with us the chipset or whatever needed in case someone wants to do locally. Um, how it would be real time? I think this is a question maybe Nigel can also take over. Uh, what if what if I want to detect more generic things like playing card, toy car, Lego set, board game? Would it be one model, multiple? How would I go about something like that? I think you will show maybe while showing the universe, right?
Yes.
What will be the output when the image doesn't contain any detection?
There just won't be any, there won't be, it'll be an empty array, essentially. The predictions will be, there'll be no predictions.
Okay. Is it worth using blurry images, low quality images to train the model? Could it make the detection more or less accurate?
Yes. So there's a step which I didn't show you in the custom model training process. We opted for the Roboflow Instant, which is just a thing that's ready to go. But in the custom model training process, which again I can walk through this happily, but you have the option of taking your data set and pre-processing it to have higher lower exposure, grayscale, and then augmenting it by multiplying your data set with different transformations applied. One of those would be a blur, for example, or flipping it, or distorting it, stretching it, or again, playing with sort of exposure and highlighting. So
Okay.
it very much helps to have a more robust model, the pre-processing step of transforming those images.
How do I run from anywhere? I tried that and got a 403 error.
Uh-oh.
403.
Um,
Forum,
I would
Discord?
need more. I think I would need more information. I'm totally happy to help, but that
Okay.
sounds like a sort of a debugging situation.
Exactly, exactly. Let's also guide to. I think it's also a little bit about trying as well. Is there a way to version the model?
Yes. So, 100%. Basically, once you create a data set, which is that versioned series of labeled images, you then build a model, and that model is also a version in unto itself. And if you don't like it, you go back, you can change the imagery, the annotations, you can change the balance of test, valid, and train, and other sort of small configurations, and have a second version or a third version or a fourth version of that model.
Okay. Great. There was one question. Um, does Roboflow API come with a universal scheme to access any model from its universe? Maybe you can show when you are in the universe page. Um,
Mhm.
is there an option to retrain a model if it doesn't meet your expectations?
Totally.
Okay.
So that's what I was just describing. Roboflow Instant is going to be just your kind of one-on-one baseline fast model. But if you go through that custom training process, there you can create an infinite number of versions of a model depending on your needs and if it's good enough.
Okay. Do we have any credits to use or build models? I think there is already something inside the free package, right, that they
Yep.
can try out. Perfect.
Yeah, and I think just as a helpful barometer, if we made a custom model today, we would have spent 1 credit with and using auto label, one or 2 credits, and you get 30 credits total.
Perfect. That's great.
So there's a ton for
Opportunity,
you to
yeah.
use.
That's great. So I think we can look at the universe now. In the meantime, I saw a question, what are the potential use cases? So just to let everyone know here, this is just one use case. We will do a lot of other use cases to make you get acquainted with this. We know that this is not an easy topic to integrate. Now it will get a little bit more complex after you saw Nigel's part as well, if you feel it's already complex. But don't worry, you are backed by SensAI Hackademy and the experts here. And for the ideation, we have actually interesting ideation rounds online and in person happening. So feel free to join of them as well to understand how these CV use cases can be implemented for smart glass or XR. Perfect. Should we show the universe quickly?
Let's do it. Let's show universe. Here we go. I'm going to share my screen. Okay, we're back in that demo space. Here are our workflows. Okay, now let's check out universe by going to explore. And our endpoint here is I'm going to find the model that Nigel will then use. And I'll walk you through my thinking of how to find a great model and data set within universe. So first of all, I am going to look up playing cards because that is what we're detecting. Okay, I'm looking. I don't know. Do I like those? Let's make sure it has a model. And let's generally, right, we don't want one with just a few images. We want maybe more than 200 is a nice bar to clear. And then let's say stars over 5. Okay, cool. So here's one, 88 stars, 10,000 images, 3 models, and then it has all these classes. Great. One thing I also really like about this one is there is a description, an overview of how it works, and even a demo here, so I really know that it's used and tested. Great. And then I go to this model, and what I can do is click one of these test samples. Okay, and these all look really good. So these are all very strong indications of this model is going to work for me. So I've now decided it's going to work for me. I'm going to copy this model ID, head back to workflows. Let's create a new one. Add a model. This will be from, we're adding a public model. A second. Add an object detection model. Here we go. And I'm going to add a public model from universe. That little step there is, maybe use a little UI sugar on that. But so what we just did is we brought in this model from universe into our project. Now I want to add some visualization. These are sort of the classic visualization boxes that we use for object detection. It's bounding box and label visualization. And then the output. All right, let's save it. Let's test this again on this same image from earlier. So this again is just like all the work has been done for us, is a pre-built, ready to go model. And there you go, ace of spades. And then the process of bringing that locally is the same as what we did earlier. But so that is sort of the beauty of Roboflow Universe, is all that stuff is sort of, there's just gems in here. So many gems of pre-existing models and data sets ready to go.
Wonderful, wonderful. What is the size of a model, typical model?
What does that mean?
I don't know. That was the question. The size of
Yeah, okay.
the typical file size.
Oh, file size of a model. I don't know. So a model, yeah, I don't know, but it's in Onyx file type, so it's obviously its
Okay.
own file type, a model. But yeah, I don't know the answer to that. Let me make a note for myself, and then I can add it into chat.
After Nigel. I want to hand over to Nigel because we are a little bit running out of time. So,
Oh no.
But thank you, Jackson. I think we have a very clear idea now. Let's first look at how we are integrating. Nigel, thank you for making this happen to have the project ready. So I think it is your turn right now to help us how we actually use these superpowers on a headset, MetaQuest. We'd love to
Hello.
hear. Hello.
I will directly start with sharing my screen. I
Perfect.
hope it's working. Thank you for the nice introduction, and also thank you, Jackson, for preparing everything for me so that I can directly jump into it now. I'll just
Wonderful.
start the presentation. And
It works.
yeah, let's dive directly into the development part of our application for the MetaQuest now and smart glasses soon. And before I do that, I was asked to read this disclaimer one time here. So this content is for educational purposes only. We do not promote gambling or casino activity. Poker is presented here as a mind sport and board game category. So what do we see here now? So basically what we will share first is some fundamentals about poker, because maybe not everyone played poker here up to now. And then we will give some general information about the project, the architecture, what components we have, and then we will go through how we built this project, and we will share, we will live demo it also, and share what it looks like. So let's start with how to play poker. So basically, there's two types of cards. There's the private cards, which each player gets individually, 2 cards. And then there will be like 5 community cards, which will be in the middle and opened in 3 phases at the end. And at each player's turn, he has the option to do one of 3 actions. Either he can fold the game, which means he is exiting this round because he don't believe into his card winning this round anymore, or he don't want to take the risk. Then the user could raise, which means he is increasing the bet because he thinks he has maybe the best cards in this round, or he just want to pretend he has. And the last action, which is possible, each user can in each phase try to call, which is just meaning he is matching the current bet and is just going with the flow. And how do we decide if there's a winner or who is the winner? So basically, it's the last player standing. So if everyone is folding the cards because they don't want to take risk, and one is taking this risk and is just the last one existing, then he automatically wins. And the other option would be if we play until the last community card was opened and everyone was calling for the same bet, then the combination of the 5 best cards would win. And for that, you use your 2 private cards and try to build the best combination of 5 cards, combining your private cards with the community cards. And basically, there's 4 phases in poker. It's the pre-flop phase, which I already mentioned. Like every player gets this 2 cards, which is just for himself. He don't share it. And when everyone is doing the actions, folding, raising, calling, or betting. And then the next phase would be the flop, where the dealer shares the first 3 public community cards. And then again, everyone can do his actions, and that's how it's continuous. Then there will be the turn with the next card, and at the last round, there will be the river. And then again, everyone can do his actions, and based on that, at the end, we decide who is the winner. So what is the best 5 combinations? We just show you here all the possible combinations you could have, from the royal flush, which is like the best combination you could have, to the lowest one, which is just like the highest card existing. And with this barometer here, we just show you like how good it would be. In general, we can just say like the more unique the combination is, the more value it has. So if you have like the highest cards like ace, king, queen, jack, and the 10, all of the same suit, here in this case, for example, heart, then that's really unique, and you have good chances, or you basically can't lose. And sometimes there's for none of the player there's any combination except the highest card. Then even just one ace in the hand can win the game. So yeah, that's the basics. There's some more detailed or some more mechanics in the game, but that's really easy to show model here. And exactly, then we want to show you shortly a demo about what we are doing today. So what you can see here is a human playing against someone with the AI glasses. In this case, here's example the MetaQuest. And you can see that the person who plays with the AI overlay basically wins every game because he always gets the assistance with the barometer, like when to do which actions. And yeah, that's what we basically want to share with you today. And yeah, you can see this tracking works quite good. We basically just used the model which Jackson was providing here. In theory, you can train it a bit more detailed, maybe adding some images to your training directly from the MetaQuest to get a better model, which understands also the camera from the MetaQuest. But like you see, in this case, it's totally already working great just by using the trained model, which was trained on general data, which Jackson shared. Exactly. So that's what we're planning to build today, or which we already built and want to share with you today. And before I go more into detail about that, I just want to give you the general structure of the project first by showing the architecture. So that's what we basically built. You can see here on the left the XR device. In our example here, it's the MetaQuest, but it could be exchanged at any point later for any other device like the new smartglasses. And right now we used Unity to, for integrating with game functions into the MetaQuest. And on the right side, you can see the edge computing, which is happening directly on the local computer, which is serving here as a server to the application. Here we have a Docker container, which is running the local inference of Roboflow, like Jackson was already sharing it with you. And additional, we have a Node.js application down here, which is just simulating the game for us so that we can know like how good a hand would perform in a simulation. For that, we run the simulation like 100,000 times per hand and get like a number which we can use for telling or showing to the user or how strong his hand is. Exactly. So from here, I would like to go directly into development. So before we go into the Unity part with the app and all the functions, I just wanted to take care that we set up the entire backend here for the edge computing. So first we will check that we have a Docker container running with the local inference server, how Jackson was also showing it to us. So I have this application here, which is showing me my Docker containers running. And right now I have a Docker container here with the actual Roboflow inference server installed. And I will just start it first. It can take some short time to start. And exactly. Then I have an application to test if it's working. It's called Insomnia. It's basically just calling the API endpoints of the server. We can put different endpoints in here and check if the server is running correctly, and we get the data which we want from it. So there's one endpoint. So the Docker container now is running on port 9001, like you can see here. And I will just call the local container and ask which models are registered there right now. So right now, the local server don't have any registered models. So because sometime in the beginning, when we use a model the first time, like Jackson was also showing, it can take some time to load the model first. So I will just add one of the models, which is the playing cards model, which Jackson already showed here. So I have this model ID, which I put in here, and I say I want to use it for object detection and share my API key with it. And then I will try to get it. So he's now saying I have this models installed on the server. And to test if it's really working, there's a different endpoint I can use. It's the inference endpoint, and I want to do object detection. And then I get give some input to the model as well. So I say which model I want to use, and I provide an image to it using a URL. and I send it to the local server. And same like Jackson also showed, I get my data back here. We see we have quite some predictions, 7 spades, 8 spades, again 7 spades, and ace heart. So just for checking if everything is correct, we can also use this image URL here and put it in. And that's exactly the predictions we also got from the model. So we know that the first part from our architecture here is working. We have a running local inference server, which is giving us the data back, which we expect from it. Then the next part would be checking that the poker odds simulation is running, which is a Node.js server, which we will also provide to you later. For that, I open here my Visual Studio code. And basically what we do is we having a Node.js server, which is using this Node.js package called poker odds. And we added some function here to do the simulation, but that's really quite basic, and I will not go into much detail here first, but in theory, you anyway just need to run it. And we will create an endpoint called eval hand for evaluation of the hand based on the hand and the board. And we give back to the user information about how good his hand is. And when we listen on with the server on the port 3000, and also that I didn't start it. So to start it, I will put in npm start for Node.js package manager, and we see the poker and evaluators running. We just check it here also in this API testing tool, and we put this URL for the endpoint also here and provide data, one for the hand, which cards we have in the hands, and which cards are on the board right now. And if we run it, we can see that we get this information based on the simulation, how often or how high was the probability of getting a specific hand. In 100% of cases, we always won with 4 of a kind, because you can see here we have ace, 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 and ace. So there's not much to change anymore, and it's a quite good hand. So in 77% of the cases, we can win with this hand. If we would change now something here, like the amount of cards, or we say we have a 7 spades in the hand instead of an ace, then it already changes down to 44% of the cases we win. Still quite good, because we still have 3 aces here, but yeah, that's how it's basically working, and that's the data we are retrieving from this server later in our Unity application. So if we go back to our architecture, we now see we have the running edge computing on our computer, and now we need to configure this Unity app to use this data to support us in the best way possible to win some poker games. So for that, I already opened and installed Unity here. I cloned our Poker Assistant project, which we will make available from today. I cloned it into a folder and opened it here. And now you can see basically the Unity user interface. And what you're seeing here in the middle basically is for the people who don't experienced developing with Unity up to now, you can see a scene of 3D objects, which is existing here. We don't have much 3D objects here because we load all our resources on runtime. But yeah, that's basically where you would see all your 3D objects. And also here on the left side in the hierarchy, you can see what type of objects we have. It's quite easy to overview here. So one thing you can already think away, like it doesn't matter right now, is because it's just the light. It's just virtual light in our environment. Then we have these building blocks here, which is provided by Meta for this VR headsets to really easily provide a way to keep starting. So even if you didn't develop for MetaQuest up to now, we could just use this Meta SDK to bring in this building blocks here. We share all the resources later, so don't worry. And basically what you just do is bring in one building block for the camera rig, which is responsible for giving us information about where's the user in the virtual space, how is he moving, so that we can change our decisions based on that, or he's seeing content based on that. In the same way, we bring in a pass-through building block, which is just giving us the permission to, instead of the virtual world, we see the overlay of the real world, so that we can see everything like we want the real world. That is just necessary to access the camera data later. And yeah, so that's really standard building blocks you can set up in minutes here. And now it gets more interesting at the last 4 points here. So we have one object which is called Webcam Texture Manager Prefab, which is a game object which is provided by Meta, which gives us the permission and the tools, utils to access the camera API of the MetaQuest, so that we can get a camera image, which we can then later send to the Roboflow API to make predictions on it. And then the next game object here is doing exactly, was also provided by Meta, and it is the environment raycast manager, which is taking the depth image of the MetaQuest. So it has additional to the normal camera. It has down here some depth image sensor, or also just some camera in some way, which provides us with information about how far objects are away from us. So with that, we are able to not just say where something is on a 2D image, but also to give us the 3D position of it in the real space. And that's quite powerful, so that we can say exactly where our cards are. Then we have one small object here. It's the hand menu activator. And maybe now I can say the next part of Unity. It's each game object has attached these type of components, which can give game objects specific properties or abilities, let it be physics or the position in space, like with transform, the rotation, or we can also give it scripts, adding scripts to these game objects to influence their behavior. And now you can see here at the hand menu activator, we have a script, which is hand menu look activator script, and we can give different reference to it in the scene, or just typing references. So this script here is getting the hand transform. This is the position of the hand in 3D space, and the center eye anchor, which is the position of my head, or the position between my eyes in 3D space. And additional, I added here a reference to the hand menu, which is the graphical user interface. If you watch here into the scene, it's quite hard to find, but it's the graphical user interface, which we will show later next to the hand. And basically what this script is just doing, we can shortly going into the script by editing it, is just using some basic vector mathematics. We just check if we are looking at our hand like we open it, or we holding it away, like it's not important to watch into our hand. And based on that, he's activating this graphical user interface next to our hand, or he's disabling it so that we don't see it entire time play. Exactly. That's the one thing. And so everything is going down to really one game object here, which is serving as a Roboflow caller and component which is implementing the entire, let's say, game logic. And you can see we have a lot of references here. I will shortly tell you about the important ones here. And what we give as a reference is the webcam texture manager for providing the webcam image to us so that we can send it to Roboflow. The raycast manager for getting 3D position in space. The position of our hand, the position of our hand, and we have this Roboflow object prefab, which is an asset which is not directly in the scene right now, but we can use it later to load it, which is looking like this. It's basically just a tracker, 3D point tracker, which we will place at any point inside the app if we detect a card on a community card we field. So that's what we use this reference for. And then what's interesting is here the Roboflow API configuration. So what we could put in here is the Roboflow model we want to use. So maybe at this point, it's maybe I give a short excursus to a different project we had, because for the hackathons, we provided the extra project. So this is our Poker Assistant here. And we provided this easy to use Meta PCA Roboflow repository, which is helping us to really easily integrate object detection, classification from Roboflow into Unity apps. It's basically something like the supervision Jackson was showing, just that it's not for desktop applications, it's directly for Unity applications, so that you can reasonably easily visualize Roboflow projects here. So that's what this calling script is also based. So we just changed it for our use case. So the Roboflow model, we just copy pasted the model, which was getting from Jackson here, the playing cards model. That's the model we are using here. Then the local server IP address of the Roboflow server. We saw the Roboflow server is running on the port 9001 in Docker, so that's in here. And we can't really put in localhost here again, because we will use the local internet to connect to the glasses. So let's put the IP address of our computer, which is providing us a server here, into here. So on Windows, for that, we would open a terminal and ask for the IP config to get that, so that we can here get our IP address in the local network, which we can then paste into here. Just take care that if you try something out like that, you should always be with your laptop in the same network than with your MetaQuest, for example, so that you can call with local addresses. Then we have the same address with the port 3000 for our simulation on Node.js server. And then what we put in here as a reference is the minimum confidence, the model or we want to have to consider predictions as important for us. Like Jackson's always showed this parameter in the workflows, that based on that, we can say like how sensitive the model is detecting. That's what we are using here as well. We can put it a bit lower here to a value of 0.65. I guess in any case, you need to try out a bit. It's also that these cards, I have here now a card set like that, can be also quite different. So that's something you could play around a bit with, or yeah, you can also fine tune the model a bit more with your camera images. Yeah, that's something you need to try out. And then I just provided some textures of the different suits of cards. from here, like the heart or spades, so that we can also load it dynamically just during runtime into these objects and also into the graphical user interface here. We have the same for the icons of the king, queen, and jack, so that we get the textures and can load it. And then we just have some more references because, for example, we can have up to 2 cards in the hand. And here's just some references to the representation of the cards in the user interface, as well as references to the slider, which is here in the user interface. The slider will show us later, like in the script, we can develop it, but the slider is showing us how strong our hand is. I told you at the Node.js server with the simulation that our hand will be getting a value between 0 and 1 based on how strong it is. So basically our slider is also just going from 0 to 1, with being at 1 at the green area at the highest and 0 at the red area at the lowest. And yeah, that's how we implemented it in our example. So now I will jump shortly into the code. Don't get scared. Just there's a lot of functions and dependencies which we have here. But basically, I need to say, because we provided this Meta PCA Roboflow or Unity Roboflow development utility kit, we already saved here like hundreds of lines because we can just use classes already provided. Like we can see here in the beginning of our script, we just have a list of all the references we were just talking about. And then what is more important is here, this function, it's the start function. So each time Unity is starting an application or a game object is getting spawned, on the scripts on this game object, the start function is always called first in the beginning. So after we start the application, we create a client, which is a Roboflow inference client. So you see, it's really easy because we already provide these classes here. And into this client, we just put our API key, which is now saved in an extra class here just as a key to have it safe in there, not to go into the GitHub. And then we have the local server IP address, which we provided as a reference up there. And after we have a client, which is will stay existing during the entire session, we will build an object pool, which just create us for every card possible, like all the different cards we have here. One game object representing that card, so that as soon as we track it, we directly can put a marker at its position. And yeah, that's after this, we will create a coroutine, which is responsible for the entire program. And that's where we will go now. So you will see the initialization coroutine here. Coroutine is basically like a parallel process we are running so that we don't block the main process to not stop rendering and important things like that. And yeah, what we need to do here first is we need to wait for the webcam texture, the camera image to be available, because after start it takes some time. And as soon as possible, we put it later into this texture 2D, which also updates later each time. And we always update this texture. So we also close that. And after that, we start a new coroutine and close this one by starting the call Roboflow function. And in this call Roboflow function, basically right now we have an infinity loop, which is just to make it simple here for sharing it with you, but you can make it dependent at a later time point so that the program is not scanning and running the entire time. Yeah, so if a text is existing, a camera image, then we update the camera image. And what we basically do is we encode it here in some way, the image into bytes. And then we create a new inference request image, also one of our special ways of using Roboflow to make it easy. And what we just put in here in this request image is is our image. And we can later send this image using our, again, really special, easy to use object detection inference request. We send it to our model to do detection on it. And that's how you also see how easy our integration is, because now we want to do object detection in here, but we can just also change it to segmentation or whatever we want to process on there, and we get that results. So after that, if we get a successful answer from the Roboflow server, we go to on response, which is going through all the detections we have and is rendering it into 3D space. And that's where we go now into the render detection. So for each detection we have, you see these cards. I hope it's working with the webcam. You basically always have two labels. It's one in this edge and it's one in this edge. So what we are doing is taking care that if we detect more than one of these labels, that we put it accordingly in dictionary and combine these tracked objects so that we can build like an average position of them in space, so that we get not just this edge of the card or this edge of the card, but we get the middle position of the card. I think it was even a question to Jackson some time ago, like, oh, can we track the entire card by training the model like that? Yeah, if it's not possible and we need to use a model like that, we can also track both labels and then take the average in the middle. That's what we are basically doing here. We're going through all the detections and get for the one with the double label the average position. And now we also need to decide, is the card a hand card if it's detected, or is it a field card? So how do we do that? So we have a hand position already. That's why we tracked it in the references. And if the card is in a specific radius of our hand, then we decide it's a hand card, and which is happening here. And exactly. And if it's not in this radius of our hand, then we say it would be a field card, and we would put it to the field card array, which we have here. We have a field card array and somewhere hiding a hand card array, which is hand cards. Yeah. And also if we detect a hand card, it could be sometime we are just detecting one card, which can be like a bit strange because one hand card logic is in non-poker networking. It could be also that we have maybe three cards, three detections here. Maybe we have some misdetection or something like that. So we always take care to have exactly two cards. And just in this case, and if they also differ from the hand cards before, we actualize the hand cards and evaluate our poker hand new. Also, if we track new field cards, we evaluate our hand new, which is basically calling our simulation server program, local edge computing program, and we get this amount of we get this strength of our hand back from it. So here you can see how it would work to call the server. It looks quite long. You see maybe here, oh, that's the endpoint we was talking about for simulation. But yeah, so that's how you would normally call APIs like that. It gets a bit out of control, I would call it. We can export it into different classes now. But that again shows like how simple and easy our custom classes for Roboflow object detection was working, because we can directly access data on it. Yeah, and that's basically how we're building it. Like I said, I know it could be all tough at once, but we will share the project with you, open source from today. And yeah, even if you don't have a MetaQuest available yet, because I saw we have quite a lot of CV people here in the call today, or people who are just interested in learning something new. It's really easy to set up, especially with the resources we provide to you. And as soon as you have one available, you could be running your own models in, let's say, minutes. So what I will do now, just to showcase everything is working, I will build the model of the application to my MetaQuest headset over here. So for that, I will create an Android APK file. I already connected the MetaQuest here, like you can see, so I can run it directly on device. And yeah, then I basically just need to build it. Exactly. Server's running, application is building. I hope I didn't forget anything. And let's see. What you're seeing, what is opening here now additional, it's called a Unity package called Android Lock. And it would be just really practical if you run these types of applications on MetaQuest, that you can see debug messages from the application as long as you're connected, or there's also Wi-Fi integration to track these packages. So as soon as I put on my headset now, you should see there's a lot happening. I can also share my view from the MetaQuest here using the MetaQuest Developer Hub. I hope it's working. Yeah, exactly. I hope you can see it now. And what you can see is what I can see. And exactly, if we watch at our hand, we see this user interface. I bring it a bit closer about the cards and the hand strength. And if I look away from my hand, we don't see it anymore. So you can see also the cards I have available here. And as soon as I open them, you can see that the cards got tracked in my hand. We have 2 times king, 1 time spades, 1 time diamond. So that's working. Then I just take for showcase 2 more cards. Let's not get too optimistic. And yeah, we see we have a small miss, but it was 4 and 4 before. I guess you're seeing it. Now it's 4 and 4. So it's working, it's tracking these cards. And since we have our luck, we will try again. Now we have a 6 club and a heart jack, which is correct. And you can always see the value of the cards. Now it's 15, which is not so high. If we get hopefully some better cards, I will try my luck. Oh, we have a king and an ace. And like you can see, it's slightly better. It's a 17 on the barometer. Because right now it's maybe some good cards, but they're also high risk. So let's see what happens after we play the flop. So we look a bit closer. Hopefully we get. So we have a jack, queen. So we are already at a barometer of 31 now, but still nothing I would go all in for. Then we got an 8 here, which is decreasing it a lot from 31 to 18. So now he don't believe in us anymore. And I will just play the last card now. and it's a club 10. Let's see if it's detecting it. And like you can see, it's 100 here now, because we have wire flush. Oh, I'm really lucky today. So yeah, club, ace, king, queen, jack, and 10. And yeah, looks like we are really lucky today. The demo is working and we got the wire flush over here. So that's basically how it's working. And yeah, I'm looking forward to share more with you soon. I'll just jump into presentation one more time. So I guess we provide this presentation soon with you. We have all resources available here to access for you. All the game objects I described to you, like the Roboflow caller object, the webcam texture manager inside of Unity, are also described here to get a really easy, fast overview about it. And we also have a collection of possible problems where it's partly also really basic things like ensure that you have a running and stable internet connection, that the MetaQuest and the server, which is your laptop in this case or computer, is in the same network. Take care that the correct IP address is inside your object here, which was also sometime a problem if I change network a lot. And yeah, take care that your servers are running, the Roboflow server, the Poker Odds server, which is the Node.js server, and that you provide the necessary permission to the MetaQuest to access your camera as well. Yeah, and like I promised to you, I go into full dia show mode again. Like I promised to you, we also provide from today the repository to you to run this project on your own, to experiment with it, to try it out, to give us some feedback. Just follow this QR code or receive the link after the session as well. And we are looking forward to hear about your experiences with it. And yeah, last but not least, the future about how we could or how we imagine to work in the future with it. So what is coming? I guess everyone was hearing about the new smart glasses from Meta. Like you can see here, it's really advanced AI glasses. It looks like normal Meta Ray-Bans. They have an in-lens display, which is high definition. It offers a full color display. Sadly, just on one of the sides, but that's something we can still use to our advantage. So if I would try to bring this project into the smart glasses, I would maybe not consider tracking this 3D position anymore. I would maybe create like a HUD system, which is just showing the barometer for the user so that he can make smarter decisions. Because if we always develop for the smart glasses, we should always think about how to make it really simple and how to provide value to the user. And the user, he sees the real world already. So we just need to overlay it with information which is helping him, like the barometer for knowing how good his cards is. The next part you can see here in the lower left is the neuroband, which is based on electromyography, which is scanning the muscle activity of the hand wrist of the user, which is providing a really new way of interface where you can make micro gestures to control your glasses. That could be used in this example, for example, to give feedback to the application running on the smart glasses, to give us a prediction about how we want to, like how strong is our hand, because we need to also consider these glasses don't have much battery lifetime. And running the entire time with camera could be quite expensive. So the user should get feedback from the application about how good his hand is or what to do, always on request. And yeah, the last thing here is on the right, which is also quite important. Meta announced that you can use your smartphone for running edge computing on it. So you basically already bring your server always with you. Instead of the computer which we showed here with running Roboflow, you could maybe in future use your smartphone as your local server to get fast inference on your images. And yeah, that's all I want to say. It's a really exciting future, and I'm really looking forward to build with that. And I'm looking forward to hear about your feedback and yeah, build on or work on this future together with all of you. So
Amazing, Nigel.
that's great.
Timing is also perfect now. Yeah, we are on the time, but I would definitely have a few last questions to be asked. One interesting thing is I also posted on socials today. Meta's first showcase was actually playing card detection. So they actually use that. If you go to Meta website, I was also at Meta Connect. I also saw that they actually use the same card detection. Apparently, this is a very popular thing. Of course, we go beyond card detection, right? We are literally creating end-to-end poker assistant app here, which is a little bit more beyond the card detection. So this is an amazing opportunity. So it's amazing. I mean, I think we can quickly ask the questions to you. There is a bunch of that, and then we can wrap it up together. Okay? So let's start with the first question was, do we need the smart glasses to support RTSP protocol to support live object detection?
It sounds like two different questions. So right now we are talking about MetaQuest, smart glasses soon to come. If we talk about protocols, we don't need a real-time transfer protocol right now for networking. What we use right now is just, I guess, Roboflow is providing a REST-based server. So we just use standard HTTP and HTTPS protocols. I think Roboflow is also providing WebSockets to have even faster communication, but I think it would have not give us any advantage on this project because we did some research on our this running times, and I think the bottleneck would be with somewhere else instead of the communication, especially if you talk about edge communications. So no, we use HTTP as and with all that.
Perfect. Will it be possible to use AR image tracker using Roboflow, like placing 3D models after detecting tracker?
Yes, exactly. So I would like to show this shortly because I also teased it like multiple times during my presentation. So additional to the poker assistant, which we showed you today, which is detecting with cards, we have also this Meta PCA Roboflow project, which we was also providing to our hackers at the hackathon before. And that's exactly like the really easy integration part. You can do all of the opportunity or classifications you can do at Roboflow. Basically, to detect anything, you just need 4 lines of code. And yeah, we used it for detecting 3D objects. Oh, it's this video. 3D objects. Okay, there's some caching problem. 3D objects, like with beers, for example, where we track the 3D position of the beers. During hackathon, people was tracking emotion or faces of people using Roboflow. We saw projects where we was tracking balls for playing ball with it. So yeah, we really have a variety of projects you can build with this tool. Here's tracking 3D objects, exactly.
What is poker odds? Does it have the business logic?
Yeah, exactly. So poker odds is basically just Node.js package, which is provided here from Cook Heat. on GitHub, which is open source available. What is it doing? You provide him your hands, and he is doing like 100,000 iterations on it, and returning to you how often it's done in the simulation. And based on that, he's deciding how good your hands could be um, uh, in this turn or in this game. And I was also testing it quite a lot, and I saw that it's quite consistent, like 100,000 iterations of simulation is enough to have a really good score, which is quite consistent over the game.
Wonderful, wonderful. Why did you put the logic in Node.js and not keep it in Unity?
It's because we used this project additional. It would be possible to port this one actually to Unity. So it's just some additional work which would need to be done to convert this one into Unity.
Is Insomnia a service similar to Postman?
Yeah, it's exactly serving the same functions as Postman. So it's like Postman, just from my experience, Insomnia got much more powerful than Postman over the last years. That's why it's my go-to tool. But sure, you can use Postman as well.
Is there any specific guide on Roboflow around integrating your models with MetaQuest? I think this is the first
That's
attempt.
what.
Exactly. What we are showing is first attempt. I just want to tell everyone like it can be maybe 2 hours today, but it took us really almost like 2 months for us to prepare for this. So what I can ask from everyone here, if you want us to continue this efforts for the growth of the community and for the benefit of the community, we would love to see you sharing what you have learned here, because we will share the recording, etc. Like, what is your takeaways? What makes you interested on this intersection of XR and AI and this workshop? If you can share this on socials and make sure that you spread the love and the passion that our team is showing, that will be amazing, because we can do maybe one more, we can do another, but without your support, it is impossible for us to keep up to even end of this year or next year. So your support is highly appreciated here. So we understand that there is actually already growing interest that we are seeing, but we want to make sure that not hundreds but thousands of people actually joining to these sessions when we work on it on a couple of months. So would love to see your posts and tag XR Bootcamp, tag Roboflow, tag SensAI Hackademy. So you can also use that as an opportunity that you are committed to this new field. So hopefully this lecture will not be the first and last one, but it will continue with support of our amazing masterminds. Um, is the same process for development for AI glasses? Do we use Unity there? Very nice question, Kavya. This is something that I will leave up to the next one, because we have some surprises there on the smart glass side. But it is a little bit different tech stack, especially the non-computer vision part. Like the Nigel's part is a little bit different. So CV models and how you train is not changing, but how you deploy to a completely different tech stack and Wearable is really changing drastically. Even the skills requirement is different. That's why we ask, are you on mostly on the Android mobile iPhone side or more on Unity side? So yeah, this will be also part of our agenda as long as we receive again interest from the community.
And what we also experienced ourselves with that is that it also changes about how we think about different ideas we want to build for these classes. Because if we have less opportunities, and that will be the case in the next few years, to visualize our ideas, it really breaks down to this point where ideas really are we need to break ideas down to really the simple thing, like what do we want to provide to the user? It's really about value. So it's it's really interesting, like that we really need to think like that deeply about what value we really want to provide to the user. And I think that helps
Exactly.
also maybe in a different way.
Smart glass use case are a little bit different mindset. So I strongly recommend that you join our ideathons, which is mostly happening online, but also in-person hackathons. Starting November, we have two more hackathons, one in Barcelona, one in San Francisco. So this will be the moment that you can actually realize these kind of interesting ideas. Is there any APK of the project? Can I run on my laptop and Quest 3?
Yes, but we didn't provide it yet because usually you don't provide binaries in GitHub. But I can just provide the binary on additional on GitHub. That's no problem. But what is coming still additional, you still need to set up the local server for edge computing. That's the point you need to still.
I think some of us are actually like a playing this as a maybe board game or with their friends, so they just want to actually see that in action. And if there's any feedback to the kit, to the APK, to the API, as you can imagine, this is really first attempt. There might be lots of things to improve. So we would love to see your feedback on our Discord server. Our team can share the Discord server again. And ideathons, we will have the next ideathon either end of October or early November, right before in-person hackathons. So you can actually join that. And yeah, some of our, as far as I see, our audience already applied for the hacks. Again, before November, I suggest that you apply because it may be booked out due to our limited seats. We have quite interesting stuff, kits, and exclusive access to some nice things there as well. Perfect. I think we have answered over 45 questions, almost 50 questions. That's amazing. Thank you, Jackson. Thank you, Nigel. This is really a pleasure for SensAI Hackademy to join forces with Roboflow, such a like authority in the whole computer vision AI space. I feel like we just started. If the community really shows interest after today with all the recordings and everything, and then they are building amazing things and refer to our workshops and kits that they have actually used it, built it, and then tag us. We will definitely make it even bigger announcements and very nice collaborations. It is our fuel. Whenever you build something, it is our fuel. If you fill the gas tank with lots of projects, ideas, sharing, caring, I think this SensAI initiative will really go further in the next couple of years. So it's all up to you, everyone here. Thanks for joining, Jackson. Anything you would like to share? There were some questions like why I need to like select Roboflow over other computer vision solutions out there. I think it's like a much more like a database, but anything that you would like to share, like how we should position Roboflow?
Nope. I think if you guys have any lingering questions, feel free to email me. I'll drop my email at the bottom there. I think I got to all the questions that I saw, both in the regular chat and in the Q&A. But yeah, again, I'm available anytime you want to reach out at jackson@roboflow.com. This has been amazing. Thanks for hosting this, Farhan and Nigel and the SensAI team. Loved it.
Thank you. Thank you very much, Jackson. Everyone, you will receive the recording this week. So after that, feel free to already share the love everywhere. I hope that it will be available also on YouTube as well. So we will share all details. Thank you, everyone, for bearing with us for more than 2 hours and hoping to see you next Wednesday with another Vision AI, which is ball tracking, which is another actually interesting, challenging topic that we would like to share with you with Christoph. And hopefully we are looking forward to seeing all of you next week on Wednesday, same time. Thank you.
Yeah. Bye.